Hello, we're doing checkpoint 5.22 from section 5.4. It says to find the net displacement and the total distance traveled in meters given the velocity function f of t is equal to 1/2 e to the t minus 2. So the net displacement is if we account for going backwards and then going forwards, the net displacement is where this will end up being. The total distance traveled will be, if it goes backwards, we have to make sure that we account for that in a positive sense, although your backwards is negative. And then the going forward is also part of what we need to get. So to find the net displacement, we just simply integrate from 0 to 2. So let's label this as net. And this is going to be the net displacement. This is the integral from 0 to 2 of 1/2 e to the t minus 2 dt. And let's go ahead and integrate that. This is going to be 1/2 e to the t. The antiderivative e to the t is e to the t. And the antiderivative of 2 is going to be 2t. And we'll evaluate this from 0 to 2. We'll put 2 in there. We're going to get a 1/2 e squared minus 4 minus, and then we put 0 in there. E to the 0 is 1. And then 2 times 0 is 0. So this is what we would have. Let's see. 4... -4, -1/2, so it's 8 9/2. So we'll say this is 1/2 e squared minus 9/2. So that is the net distance traveled. So this accounts for going forward and backwards. Going backwards makes it negative, going forwards makes it positive, and then this is the total. All right, now to get the total distance traveled, what we need to do is we need to know if this thing ever goes negative, and we can do that by setting the function equal to 0. So we're going to let the function 1/2 e to the t minus 2 equal to 0. And solve for t. So we'll add 2 to both sides. We'll multiply by 2. So that's a 4. E to the t is equal to 4. And t is equal to the ln of 4. Now, ln of 4, if you put that in the calculator, is a number between 0 and 2. So within your interval, from 0 to 2, there's going to be an ln of 4 here. And you can check by putting a number, like maybe put 2 into the function. You have 1/2 e squared minus 2. That's going to be a number that's going to be pretty large. And then this, you put a 0 into the function, you're going to get -2. So you're going to be at the negative side. And so it looks like your graph would look something like this, and we have a negative contribution down here and a positive contribution down up here. And so we would want to integrate this from 0 to ln of 4 and then throw a negative sign in front because we're anticipating that integral to be negative, and we want to account for it in a positive way. So the total distance traveled will be equal to the integral from 0 to ln of 4 of this function, but with a negative in front of it because it gave a negative contribution down here, and so we want to undo the negative to make it positive. And then now we have a positive contribution from ln of 4 to 2 of the 1/2 e to the t minus 2 function. And so now we just integrate both of these. The integral is already here. or the antiderivative is already here. So it's just a matter of putting in the 0 and the ln of 4, the ln of 4, and the 2 into that. And what I could do is I can tell you because the antiderivative is already here. Let's skip a few steps and just get to the actual value. So the value here with a negative, and then the integral itself is negative, so it ended up being positive, and that would be a 1.27259. And here, the antiderivative here, after you do the evaluations, would be 0.46712. And so we would add that and get the final result to be approximately 1.7397. Okay. So this thing here looks like this is this negative area here. These are approximately equal to, it's not negative because the negative here made it positive. So that's what that is. So anyways, the integral from 0 to ln of 4 gave us a 1.27 something, which means the area here is probably bigger than the area that we found over here, which is only 0.4. And so if you would have plugged this into the calculator, you should probably get a negative value. Because this is supposed to be a bigger negative value. All right. I hope that helps.